Through your discoveries with parallel lines and transversals, you should have discovered 4 different postulates or theorems. The first one that we look at is the corresponding angles postulate. And that says if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So, this is a postulate. We know this to be true. It does not need to be proven. So what I have here is this little diagram. Here's angle 3 and angle 4. Those are corresponding angles. They're in corresponding positions. When the lines are parallel, cut by a transversal, they are congruent. And I like to highlight them to see, it kind of looks like a letter F. If you were to take this picture and rotate it, you could have an F like this. You could have an F like this, or you could have on the side, but anywhere you kind of see that it looks like an F, that's where you find your corresponding angles. Okay, so this doesn't need a proof because it is a postulate. But our next one that we talk about here is a theorem. Okay, so this is the alternate interior angle theorem, and this theorem states that if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. It is a theorem, so this theorem is actually proven based upon different definitions and postulates, and actually the corresponding angle postulate is going to help us prove this. When you look for alternate interior angles, you will see that it kind of looks like a Z. I always find the Z. Do you see the Z? It looks like alternate interior angles. So even if, this is a little trick that I do, if you like put a little line here and a line here, you see it kind of looks like an A, I, A. See that? Isn't that interesting? AIA for alternate interior angle. Well, you see it or you don't. I see it. I think it's cool. Oops. Wait, I want to erase all that so you can kind of see it. All right, so when you look at a figure and you're looking at transversals with parallel lines, those alternate interior angles are congruent. Okay, look for the Z. Now, as I said, this is a theorem. So in order to add it to our reasons bank, we do need to prove it. Okay, so let's go through the proof of the alternate interior angles theorem. So I have my diagram. My given, make sure you write all this in your notes. So we have our given information. P is parallel to Q, and what we are trying to show is that angle 1 and angle 2 are congruent to one another. All right, so we already know about the vertical angles theorem, and our corresponding angles postulate is going to help us out here. So if you know the lines are parallel, well, you always know that angle 1 and angle 2 are congruent. Always, because they're vertical angles. So we're going to say angle 2 is congruent to angle 3, and that's your vertical angle congruence theorem. Okay. Looking at the figure, you also know that angle 1 and angle 3 are corresponding angles. So those angles are also going to be congruent. So angle 1 is congruent to angle 3, and we're using the corresponding angle postulate. Okay? And remember, that's when the lines are parallel being cut by transversal, corresponding angles are congruent. And now, think about your proof statement here. We're trying to prove angle 1 is congruent to angle 2. Well, we know angle 2 is congruent to 3, and 3 is congruent to 1. So through a substitution, we know that angle 1 is congruent, why did that just do that? I don't know, to angle 3. Oh, nope, that's not what we want. We want angle 2, sorry. And this is all mashed up. I don't know what the heck happened. This notepad that I have kind of messes up. All right, so let me try this again. So statement 4, and we are showing that angle 1 is congruent to angle 2, and this is substitution. It could also be transitive property, right? Transitive property, we've talked about that. The book would call this a transitive property, or we could call it substitution. So now that we prove this, you could add it to your reasons bank. Alternate interior angle theorem. So you could abbreviate that in your reasons bank, alternate interior angle theorem.